So one of the big questions we've been looking into when you watched a heavy object like a bowling ball and a feather, light object like a feather, dropped at the same time, and in air the bowling ball hit way faster than the feather. But in a vacuum, they both fell and hit the ground at the same time. So why in air? Like, what's the reason why a heavy object will, or dense rather, object will hit the ground before a lighter object like that feather? All right. So what I have listed here, I want you to copy down. For light objects, I wrote a few examples of how fast they travel when they get to their terminal velocity. So they're going to speed up when you first drop them, and these are the top speeds they're going to hit. And they're going to stay at that speed the rest of their fall. Denser objects, though, like a skydiver or bowling ball, they speed up, and they speed up for more time, and they get to a higher speed. But once the skydiver hits 120 miles per hour, they continue falling at that speed. They never actually speed up to 130. And the bowling ball, once it gets to 60 miles per hour, it's never going to fall faster than that. It's going to stay falling at that speed, okay? So you can imagine a speedometer on these objects, and the skydiver's going up, 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 and then the speedometer stays at 120 as it's falling. All right, so basically, a heavy or dense object is able to, once it gets to terminal velocity, travel faster, and that's why it hits the ground first, okay? But a light object, like a snowflake, once it gets to like 5 miles per hour, and that's a pretty dense snowflake, you know, but that's the fastest it's gonna go, and it's gonna continue falling at 5 miles per hour. So a dense object, write this down, has a higher terminal velocity. So when you look at that, that's the terminal velocities of the dense objects right there. And because they have a higher terminal velocity, they're able to fall faster for the great deal of their fall, okay? So I want to now, and you might need to do this on the next page, continue with the light versus dense idea. How does their fall look different? How does a light object's fall look different than a dense object if we were to draw a strobe photo? Let's draw a light object strobe photo and then a dense object's strobe photo, okay? These are the force diagrams. We're not going to draw those. We're just going to draw the strobe photo, okay? Just the dots, okay? So for a light object, first it starts speeding up like this, okay? But once it gets to this spacing right here, you see the spacing goes from small to a little bigger, so it's accelerating. But once it gets to this spacing right here, it continues falling at that meager spacing. So the part where it's at constant velocity, it has a low constant velocity. But for a dense object, really starts falling the exact same way. The first 3 dots look the same. But maybe when it gets to this line where the light object hit 5 miles per hour and it stayed at 5 miles per hour the rest of its fall, that's a good example. Maybe that's 5 miles per hour, that spacing right there. The dense object, I shouldn't draw that. It hasn't hit terminal velocity yet. Remember, the dotted line means, oh, we hit terminal velocity. We're not going to speed up anymore. But the dense object still is going to speed up. It's still going to gain more spacing. I'm going to draw 2 more dots where it gains more spacing. And then it hits a dotted line to say, oh, this is the highest speed. It hit that spacing right there. And that's the spacing we're going to continue on with the rest of our fall, okay? So draw maybe a few more of that large spacing, okay? And these are all equally spaced here, okay? So that's showing a constant velocity. But what kind of constant velocity? Eventually, the dense object eventually gets to a constant speed. It just takes more time. That's why I drew the dotted line lower, because it took more time to get to constant velocity because it still needed to speed up. So a lighter object, it hits its terminal velocity first, and it's going slower when it gets to terminal velocity. So get to terminal velocity first, and it is also going slower once it is at terminal velocity. So how do we know it gets the terminal velocity first? The dotted line is higher. For the dense object, how do we know it gets to a faster terminal velocity? Look at the spacing after the dotted line. The spacing is greater.